Now, what if you were to see an expression that looks like this? What is the antiderivative of x squared sine x cubed dx? What would you do in a problem like this? Now, there's a technique called substitution, and you want to replace all the x variables with u variables. I'm going to make u equal to x cubed. The reason being is the derivative of x cubed is 3x squared, and the 3x squared in this expression can cancel with the x squared in that expression, which is what we want. Now, in the next step, solve for dx. Do divided by 3x squared is equal to dx. So, what we're going to do is replace x cubed with u, and dx with do divided by 3x squared. So, this is going to be x squared sine u do over 3x squared. So, notice that the x squared cancels, and let's take this constant and move it to the front. So, we now have is 1/3 antiderivative sine u du, and we know what the antiderivative of sine is, it's negative cosine, so this is negative 1/3 cosine u plus c. Now, at this point, all you need to do is replace the u variable with what it was in the beginning x cubed. So, the final answer is negative 1/3 cosine x cubed plus c. Let's try another substitution problem. Try this one. Do you think we should make u equal to x squared plus 5 or 7x? Notice that the derivative of x squared will give you 2x, which can cancel the x and 7x. So you want to make u equal to x squared plus 5. So, do is going to be 2x dx and then solve for dx. Dx is do divided by 2x. Now, we need to replace x squared plus 5 with u, and dx with do over 2x. So, this is going to be 7x raised to the u, or times u raised to the 6th power, and then times do divided by 2x. So, we can cancel the x variable, and the constant 7 over 2, let's move it to the front. So, let's put it on the left side of the integral. So, this is 7 over 2, u to the 6th, do. Now, we can use the power rule. So, if we add 1 to the exponent, it's going to be u to the 7th, divided by 7, plus c. So, notice we can cancel these 7's. So, what we now have is 1/2, u to the 7th, plus c. At this point we can replace u with x squared plus 5. So, the final answer is 1/2, x squared plus 5 raised to the 7th power plus c. So this is it. Now, let's try this problem. What is the antiderivative of tangent x? You can either know this answer, or you could find a way to get the answer. So, what can we do? Now, tangent is sine divided by cosine. So, in this form we could use substitution. Let's replace u with cosine x. If we do that, the derivative of cosine is going to be negative sine, and if we solve for dx, it's going to be do divided by negative sine. Notice that the sine variable will cancel. So, let's replace cosine with the u variable and let's replace dx with do divided by negative sine. So, the expression that we now have is the antiderivative of negative 1 over u. If you recall, the antiderivative of 1 over x is ln x. So, for 1 over u it's ln of u. Now, we can replace the u variable with cosine. So, we now have is negative ln cosine x. Now, there's a 1 in front of here. A property of natural logs allows you to take the coefficient and move it, inside of ln. So this is going to be ln cosine x to the negative 1 power plus c, which is the same as ln 1 divided by cosine x. Now, 1 divided by cosine is secant. So the final answer is ln secant x plus c. That is the antiderivative of tangent x.